Hey guys, so today we are looking at parallel and perpendicular lines. So our learning goal is to solve problems involving them, but to be successful at this, we ultimately need to determine whether or not a line is parallel or perpendicular to each other. So in your vocabulary list, I want you to define the terms parallel, perpendicular, and collinear. Let's talk about parallel lines first. So parallel lines are two lines that are never going to meet, and we've seen this in, I think it was like grade 7. And you have two lines, and those two lines, those two lines are going in the same direction, and they will never, ever, ever meet. They will never, ever, ever cross over. And usually we represent parallel lines using some sort of symbol. So we could use a line. Typically, I think your textbook will use arrows. If you've got two sets of parallel lines in a shape, so say, for example, you've got a parallelogram, you know that these two lines are going to be parallel, and then these two lines are going to be parallel to each other. Okay, so that's how we know that two lines are going to be parallel or not. Now, to know whether or not two lines are going to be parallel, we have to know whether or not their gradient is the same. Okay, so we need to show that the following line AB is parallel to CD, given that A's coordinates are -1, -5, B has coordinates 5 and 7, C has coordinates -3 and 1, and D has coordinates 4 and 15. So what I'm going to do is I'm going to just quickly sketch this situation. All right, I've drawn in my graph and I've drawn in my points. I've also indicated where the lines are going to be. So the line AB is this line connecting these 2 points here, and then line CD is this line connecting these 2 points here. Now we have to show that they have the same gradient, because if they have the same gradient, that means that they are going to be parallel. Because you think about it, right? This is going to go up and up and up forever in the same direction, and this is going to go up and up and up forever in the same direction. So they're never, ever, ever going to cross over. Same thing going back down this way. They're never going to cross over. If the gradients were even slightly different, so if I had a gradient like this, and then let's say I had a gradient like this, right? Very subtle difference, but eventually you can see if you were to go back far enough in the line's history, there would be a point where the lines would actually cross. So if they have the same gradient, they're going to be parallel. If they don't, they're not going to be parallel. All right, so to do this, we actually need to go through and we need to find the equation of each line. So I've actually done a video on this, so it's called Determining Linear Equations. If you go back and have a look in the Year 10 Specialist playlist, it should be hanging out in there somewhere. So what I'm going to do is I'm going to find the equation of this line here, AB. So to do that, I've got 2 points, so I'm going to use the 2-point method. So that means that I need to find my gradient first. So I'm going to do that using my formula. The gradient is equal to y2 take y1 over x2 take x1. And let's pick the point. So this is going to be my x1 and my y1, and this is going to be my x2 and my y2. All right, so let's go ahead and let's substitute those values in now. So y2 was 7, so 7 take away -4. Divided by 5 take away -1. So that's going to give us 11 over 6 for our gradient. So now what we can do is we can substitute that into our other formula that we use when we're determining the line of an equation from 2 points. So y take y1 is equal to mx take x1. I'm just going to pick one of my points, so let's just pick 5 and 7. So y take away 7 is equal to 11 over 6, and then that's going to be x take 5. All right, let's expand this out so that we have y is equal to 11 over 6x. This becomes minus 55 over 6 plus 7. I'm just going to quickly chuck that into my calculator. Okay, so then this is going to give me -13 over 6. So y is equal to 11 over 6x minus 13 over 6. Now we can change that to proper form, but I'm just going to leave that as it is for the moment. All right, so that's the equation of the line. I don't even think I really need to go that far, really, did I? So all I really needed to do was I just needed to work out what the gradient was going to be, because these are obviously going to have different y-intercepts because they cross at different places. Okay, well, let's try that again, except this time now let's try it just calculating the gradient and not wasting my time. So the gradient of the second line, so this is for the line CD, is going to be m is equal to y2 take y1 over x2 take x1. So this time this is going to be my x1 and my y1, and this is going to be my x2 and my y2. All right, let's substitute those values in. So 15 take away 1 divided by 4 take away -3. So that's going to be equal to 14 over 7, which is equal to 2. So they're not actually parallel because they have ever so slightly different. I'm just going to go back and double check my working for this one. So this was definitely 7 and definitely -4. Yep, that's definitely going to be 11 over 6. This is definitely going to be 2. So that means that they are definitely not going to be parallel to each other. All right, so I want you to have a go. Just have a go at the first sort of 3, so A, B, and C. I'm going to give you time to pause, and I'm going to come back with the solution just for A after the break. All right, so let's go through and let's find the line AB. So we can draw the picture again. I'm not going to do that, however. I'm just going to use that method that we used previously to work out the gradient for each of the lines, and then I'm going to see if those are the same. So this is just for A. So let's find the line AB first. So the gradient of the line is going to be equal to, y2 take y1 over x2 take x1. So in this instance, let's call this my x1 and y1, and let's call this one my x2 and my y2. So y2 is going to be 9 take away 13 divided by 2 take away 4. So that's going to give me -4 divided by -2, which is going to just be 2. All right, let's do the same thing now for CD. And again, I'm just going to call this my x1, and I'm going to call this one my x2. So we're going to have m is equal to y2 take y1 over x2 take x1. So y2 is going to be 0, 0 take away -10 divided by 15 take 0. Well, this is a nice easy one, isn't it? So 10 divided by 15, and that's going to be equal to 1 over 3. So clearly those two lines are not going to be parallel. Let's just quickly go back in and let's double check my working. So 0 take away -10 is definitely 10, 15 take away 0, yep, that's definitely right. Okay, oh, this is where I stuffed up. 2/3. Good. Okay, so this one, let's double check this one. So 9 take away, well, let's do it the other way. 13 take away 9 is 4, and then 4 take away, yeah. So that one's definitely correct as well. So they are definitely different. All right, so now I want you to go through and have a go at question 2. So which pairs of the following straight lines are parallel? So to do that, you may have to rearrange some of these equations. So I'm going to show you how to do the first one, just to rearrange. So we want to express in terms of y. So that means I want to move the 2x and the 1 over to the other side. So I get y is equal to -2x minus 1. Now I'm going to go around and I'm going to see if there are any other values that have -2x. This one, let's rearrange this one as well. So we have y by itself. So what I would do, I'd add x to that side, divide by 2. No, that's going to be different. That's going to be different. Divide this whole thing by 3. Nope, that's going to be different. That's still going to be 3x. That's still going to be 4x. Oh, this one, we might rearrange this one. So if we subtract 6x to this side and then we divide through by -2, oh, we get +3. All right, last one. Okay, nope. So none of these are going to be parallel to this first one because this is the only one that has a gradient of -2. So that's all we have to do, is we just have to get it into that slope-intercept form and then compare the gradients. Okay, so let's have a look at some collinear points. Now, collinear is a new term. We haven't actually talked about this yet. So if we have all of, like say we have 3 or 4 points and they're all on the same line, they're called collinear because they share a line. So we can determine if they're on the same line by using the equation of the line. So again, I've got 2 points here. I'm going to work out the gradient and I'm going to work out the equation of the line. So I'm just going to use A and B. So the gradient, let's do this really quick, is going to be equal to 1 take away 0 divided by 4 take away 2. So that's going to be equal to 1 over 2. So that's my gradient. The next thing I'm going to do is I'm going to substitute some points in, because I know this is going to be a half x plus c. So I'm going to substitute in 2 and 0 to find my value for c. So 0 should be equal to a half of x plus c. So c must be equal to -1, because this here would be 1, and so if I move it over the other side, it will be -1. All right, so now I have an equation of the line, so 1/2 x minus 1. Now to determine whether or not they're collinear, I found the equation of the line using A. I'm now going to see if B is on that same point, so I'm going to substitute in these values and see if the left-hand side is equal to the right-hand side. So 1 should be equal to a half of x minus 1. So a half of 4 is 2. 2 minus 1 is equal to 1. The left-hand side equals the right-hand side. So therefore, we know that A and B are going to be collinear. Let's do the same thing now with this last point here, C. So let's substitute in 10 and 4. So 4 should be equal to a half of 10 minus 1. A half of 10 is 5, and 5 minus 1 is 4. So the left-hand side is equal to the right-hand side again. So therefore, the points A, B, and C are all going to be collinear. I'm just putting a tick because I only have a certain amount of time to get through these videos, as we know. All right, so I want you to have a go now at the next couple of questions. So show that the points A, B, and C are collinear using that same method as what I've just done. So find the equation of the line, substitute in values for y and x, and see if they all fall on that same line. And then show that the line that passes through the points -4, 9, and 0, 3 are also collinear, or pass through the points 6, -6. So again, it'll be using the same method. All right, so the last little section for today is going to be on perpendicular lines, but I'm actually going to run out of space. So I'm going to talk about this in the next video. So talk soon. Bye.